Hello again, everyone. Dr. Tom McNamara back for our course in trigonometry. In this video, we are going to continue our work with the double angle formulas for sine and cosine. We're going to prove some additional identities, and we're also going to look at an application to graphing. So, to review, these are the double angle formulas. They come from the angle addition formulas for sine and cosine. We derived these in our last video. So sine 2a is equal to 2 sine a cosine a. When you're talking about the double angle formula for cosine, you have a choice of 3 different versions. One of them involves both sine and cosine, exclusively cosine and exclusively sine. So whichever application works best. I want to start out with this example right here. We're going to prove that sine 2x minus 4 cosine x times sine cubed x is equal to sine 2x cosine 2x. Alright, so following our general strategy, I'm going to start with the more complicated side. So I'm going to rewrite over here sine 2x minus 4 cosine x sine cubed x. Now that is equal to, right here, I'm seeing a double angle formula, so I'll apply that. 2 sine x cosine x. Now that just applies to this first term. 4 cosine x sine cubed x, that's going to remain unchanged for now. Now I'm noticing some common factors here, some things that are in both of the expressions. They both have factors of 2. They both have sine x. In fact, this has 3 factors of sine x. And they both have a cosine. Okay, so I'm going to factor that out. Now from this first term, I factored out everything, so I'm going to leave a 1 there. Okay, I had a 4, I took out a 2, so that would leave me with a 2. The cosine is gone, and so is one of the factors of sine cubed. That would leave me with 2 factors of sine. Alright, now let's look at our double angle formulas back up here. Sine 2a equals 2 sine a cosine a. Okay, notice what I've got right here. That is the double angle formula for sine. And let's look at this second factor. Notice this is one of the versions for the double angle formula for cosine. Okay, so I'm going to apply both of those. This is sine 2x, and this is cosine 2x. And look at what we were asked to do up here. We had this expression, which is what we started with. We started with the more complicated expression on the left, and we were supposed to turn it into sine 2x cosine 2x. And we did that with a couple of applications of our double angle formula. Alright, so very nice application to identities. Okay, let's do another example where we apply the double angle formulas. Okay, in this example, we are asked to graph y equals eight cosine squared x minus 4, 0 less than or equal to x less than or equal to 2 pi. Alright, so we have talked about graphing trig functions before, but we haven't looked at something that involves the square of a trig function. We haven't done that yet. So the basic idea that we're going to follow here is we are going to use our double angle formulas to simplify this expression. Okay, so first thing I'm going to do is notice that both of the terms have a factor of 4. So I'm going to take that out. Now, after I factor out the 4, I'm looking here at 2 cosine squared x minus 1, and I'm thinking about my double angle formula for cosine. That's one of the versions of it. Okay, so it's cosine 2x. So this initial expression collapses into this one. So my period is pi, right? We can take 2 pi, divide by this multiplier, and that'll tell us the period is pi. My amplitude is 4. All right, so let's go ahead and get to graphing. One, 2, 3, 4. Okay, that's going to be one complete cycle. 1, 2, 3, 4. The problem did ask me to go from 0 to 2 pi. Okay, let's do this here. So that's 4. And down here is minus 4. The graph is going to oscillate between minus 4 and positive 4. Now we got a cosine function, so we start up at the top of the cycle. We go down to the midline. We bottom out, back to the midline, up top. Connect these with a nice smooth curve. Remember, no angles in our trig functions. And then we repeat. Okay, so this is a graph of that function on the interval 0 to 2 pi, and the way we got the graph was to take the function that we originally had, which was this right here, involving cosine squared, was to take the function and simplify it through an application of the double angle formula. Just to kind of be complete here, that's pi over 4, pi over 2, 3 pi over 4 right here, the tick marks on the x-axis. Remember, we take the period, we cut it into 4 equal pieces, and go from there. Okay, so we could identify all those in that way, and get a really complete graph by extracting the essential information from this formula after we've simplified it.